Good morning. This is a PowerPoint presentation on how the sun produces heat and light. This PowerPoint is in partial fulfillment of Physics 2020 Project 2, and this PowerPoint is by Rochelle Jefferson. First, let's talk about the sun. The sun is a beautiful, huge glowing star that is located at the center of the solar system. The sun is important to humans because it provides humans with vitamin D source. The sun is also important to plants because it helps plants with photosynthesis. The sun is made up of about 70% hydrogen, 28% helium, 1.5% of nitrogen and oxygen, 0.5% of magnesium, sulfur, neon, iron, and silicon. The sun uses its gravity to hold the other planets in the solar system together. This gravity keeps particles, debris, and other planets in their orbit. So, in other words, it keeps everything basically in their place. It helps everybody and all the planets stay in their lane. Electromagnetic fields is also used by the sun. Electromagnetic current in the sun produces a magnetic field that is carried out through the solar system by solar winds, a system of electrical charged gases blowing outward from the sun in all directions. In this side, in this slide, you can clearly see in blue the magnetic field that is actually moving around the sun. The sun is the yellow glowing star that's in the middle of this slide. The green dots outward are the neutral current sheet, and the red lines shows the solar wind flow from the sun in this PowerPoint slide. The leading cause of light on Earth is the sun. Sunlight makes available energy that green plants process to generate sugars to create starches, which is now released into living things that digest them. Sunlight is not also important to plants, but it's also important to us as humans. A lot of times we don't get enough vitamin D in our diet through milk and other products that we digest that is rich in vitamin D. We also get vitamin D through sunlight. This sunlight that helps us to generate and produce more vitamin D also helps with us in our bone density so we don't go around here breaking bones and stuff when we get older. In physics, the term light occasionally talks about electromagnetic radiation of any wavelength, no matter if it's visible to the human eye or not. Electromagnetic radiation wavelength ranges from gamma rays with the wavelength less than 1 times 10 to negative 11 meters to radio waves that measure about 1 meter to X-rays and microwaves. Within that wide range spectrum, the wavelength visible to the human eye inhibits a very slim band. This band has a range of about 700 nanometers for red light down to 400 nanometers for visible light. Compared to all types of light, visible light is released and taken in by tiny packets called photons and are characterized as waves and particles. The sun makes light through the process called nuclear fusion. Nuclear fusion is a reaction in which two or more atomic nuclei come close enough to form one or more different atomic nuclei and subnuclei particles. The alternation in mass among the reactions and products is demonstrated as a discharge of big sums of energy. This variance in mass comes from the alternation in atomic binding energy among the atomic nuclei at the beginning of the reaction and at the end of the reaction. Fusion is the procedure that influences or puts in motion the main sequence stars or other high magnitude stars. Light is produced in the sun's core. The core of the sun is extended from the center of the sun to 0.25 solar radians. The core is the hottest part of the sun and therefore the hottest part of the entire solar system. It has a density of 150 grams per centimeters cubed, which is about 150 times the density of liquid water at the center of the sun, and a temperature of 15 million degrees Celsius. And the sun's core, it is filled with a lot of high energy and moving particles. And in this PowerPoint slide, I'm trying to show you that the different parts of the sun, which is the solar storm, the radiation zone, and the core. High energy movement of the particle causes them to constantly run into each other. The constant colliding with each other causes a chain reaction of nuclear fusion, and this chain reaction is what actually makes light. The first collision in the sun's core is amongst two hydrogen nuclei atoms. This first collision outcome is called deuterium, also known as heavy hydrogen. Heavy hydrogen, or deuterium, contains one proton, one neutron, and gamma rays. The next part of this reaction is that the deuterium crashes into a proton, producing a helium-3 with a configuration of two protons and a neutron. The third reaction is when the two helium nuclei hit each other to produce a stable helium nuclei, which has two protons and two neutrons. So it takes three of these nuclear fusions happening in the core of the sun to produce four proton nuclei to make a single helium nucleus. The energy richest proton that they produce are called gamma rays. Since the sun makes high-level energetic light during nuclear fusion in the core, the condition must be just right for these spontaneous reactions to occur. The energy that reaction gains from nuclear fusions have to be greater than the energy being supplied. This is clearly where Einstein got his world-famous equation E equals mc squared. This entire group of energy exists from the reaction in the form of gamma rays. The nuclei created through the nuclear fusion reaction stays inside the sun's core. Nevertheless, the gamma ray starts to move towards the Earth. All of the sun, not only the core is densely packed with matter and gamma rays colliding with many particles until they reach the sun's surface. Because of these collisions, a gamma ray would take about 100,000 years to make it to the Earth's surface to give the world light. Depending on the number of collisions it took for the gamma rays to reach the surface of the Earth, it has more or less energy left. At this fluctuating energy level, they are not called gamma rays anymore. They are considered to be just general old photons. Now that there is nothing for the photons to collide with each other out there in space, it's only a minor step to move at the speed of light, or 8.5 minutes, to reach the Earth and give us light. Next, we will be looking at how the sun creates heat. The sun is the source of most of our heat on Earth. Heat, or energy, from the sun is used to produce electricity, heat our homes, and solar cooking. Heat is defined as the amount of energy that flows spontaneously from a warmer object to a cooler object. In physics, heat is described as a form of energy associated within the motions of atoms, molecules, and other particles made up of matter. Most scientists classify this type of heat as energy in motion. Scientists have proven through scientific experiment that 99% of the sun energy takes place within 24% of the sun's radius. Heat moves through a process called radiation. In physics, radiation is defined as the emission or transmission of energy in forms of waves or particles through space, a material, or medium. Nuclear fusion is not only used in the production of light, it is also used in the production of heat as well. The sun's core is the only part that produces a significant amount of heat through fusion. The sun's core is a part of the sun that extends from the middle of the sun to about 20 to 25% of the solar radius. This is where energy is produced by hydrogen. In turn, the hydrogen atom is then converted into nuclei helium. This is possible thanks to the extreme pressure and temperature that exists within the core. which are estimated to be equivalent to 250 billion atmospheres and 15.7 million Kelvins, respectively. The outcome of this process is the union of four proton hydrogen nuclei into a single alpha particle. Two protons or two neutrons come together into one particle that is the same as helium nuclei. Two protons are free from this process as well as two neutrons. And energy. This energy is now turned into electromagnetic radiation. Electromagnetic radiation is the form of energy that reaches us on Earth and gives us heat. In conclusion, light and energy from the sun is very important for humans, animals, and plants to survive. We never really pay attention to how much the sun impacts our lives. We just get up in the morning and expect it to be there. But we rely and need the sun in almost everything that we do. Plants need sunlight in a process called photosynthesis to provide Earth with food for all life. Light and energy from the sun helps humans to take in vitamin D. Scientists say that the light from the sun can help you live a healthier and happier life. The sun's energy from light can help us to stay warm, help us to cook food, provide energy to our homes. Even though we cannot physically touch the sun is always physically touching us. Thank you. This is the word cited page for this PowerPoint presentation.